Welcome, students. Welcome to my live class. Today I am going to explain here about relation and function. Okay, what is relation and what type of question will be there in relation, and what is function and what type of question will be related to the function. Okay, that I am going to explain here. Okay, here let's start the topic relation. Okay, what is relation? First of all, we should know about it. Okay, okay, let's start with the definition of the relation. Okay, first of all, you have to write here relation is a subset. Okay, right here, first of all, definition relation is the subset of Cartesian product. Okay, right here, relation. Okay, relation is a subset of Cartesian product. Okay, subset of Cartesian product. You have to write here, and I will show here how Cartesian product. Right here, SIEN. Okay, this I. Okay, here Cartesian. Okay, Cartesian product. Right here, like this. I will show you here how relation comes. Okay, first one, the relation is the subset of. Okay, subset of also you have read. Okay, here relation the subset of, right here, of. Okay, relation is the subset of Cartesian product, right? What type of Cartesian product? Cartesian product of two non-empty sets. Okay, product of, right here, two non-empty set. Right, the two non-empty set. Non, then right here empty set. Okay, two non-empty set. Right, two non-empty sets you can write. Okay, and here I'm going to show you in symbol, right here, relation. Relation is the set of order pair. Okay, that is the set of order pair. This order pair is taken here as a xy. Okay, here xy set of order pair, right, x comma y. Okay, then this set is the set of order pair in which, in every order pair, first component, that x should belong to. Okay, x belongs to set A, right? You have to write this, and you can write here comma, also you can write here this y belongs to, this is the symbol of belongs to. Okay, this belongs to set B. Okay, this is the symbol. Okay, x is relation to y. Okay, here is given, it is symbolically, we write it, it is written as, you can write here, it is written as, right here, it is written as, right here, it is written as RITTN, it is written as, it is written as, right here, capital R. Okay, and here you can write relation from x to y. Okay, okay, it is read as x is, that is, it is read as x is related to y. Right here, it is, it is read as, right here, read as, okay, as, right here, it is read as x is related to y. Right here, x is, x is related to y. Related, right here, RELATED, x is related to y, right there, like this. Okay, x is related to y, right? We do like this. Okay, this is the definition of relation. This is the, okay, definition of relation. Okay, children, and look here, it is some of the parts of this definition is hidden there. That's why I'm bringing this photo down. Okay, okay, now it is clear. This photos, I'm keeping it down. Okay, I'm doing this setting something. Okay, look still in there. That is the definition of relation. Okay, some of the strings like here is the name. The people name is given there. Fruit. What is unique name there is fruit name is given there. Okay, and here is given like this. Okay, and now this is the definition for the relation. Okay, x is related to y. X is related to y. Then look here. I am going to clear this definition of the relation. Okay, here I want to just change some setting here. Okay, And then now this is the definition of relation. Okay, this I want to clear and write here a little bit down. Okay, relation is a subset. Okay, of right here Cartesian product, right? Is the subset of the right here Cartesian product. Cartesian product. Okay, the subset of the Cartesian product right there of Cartesian product of two Cartesian product of the two, right, non-empty. We have to write the non-empty, non-empty, non-empty sets. Okay, you have to write it sets, and it will be written as like this. Look here, in symbol you have to write here relation. Okay, is the set of Cartesian product. This is the symbol of set, that's curly bracket, and we write the order pair as x comma y. Okay, and so that, and in this x comma y set of order pair, x belongs to this first component belong to always in set A, and there is y belongs to set B. Okay, like this, and we it is written as, look here, right there, it is written as it is it is written as it is written as relation. Okay, R we have written, that is x is related to y. Okay, x is related to y, we have to read like this, and we have to write like this also. Okay, and written as there is, okay, this is it is written as x is related to y. Okay, this is the symbol also, and I want to make you clear about this. Suppose there is set A. I want to show you one. I want to show you one here. Set A is given there 1 comma 2. Okay, and there is set B. Set B, suppose there is given this is suppose 3 and 4. Okay, this you can write 3 and 4, 3 and 4, and right here A cross B. We have to write the A cross B. Okay, Suppose here A cross B, this is the Cartesian product. If you write here Cartesian product, we know Cartesian product is product of the two set, and write here set A is what there 1 comma 2, and we have to write the cross, and the set is there 3 comma 4. Okay, this is comma. Okay, and in this 3 comma 4 and this 1 comma 2, how to find the product? Look here, and we're finding the product means first of all this one makes the pair with 3. Okay, 1 comma 3, this is Cartesian product, and 1 comma 4, 1 comma 4. Okay, now it's turn off 2, then make the order pair from 2. This is 2 comma 3 first. Okay, 2 makes order pair with 3. Then next one is there 2 comma 4. Okay, like this is the relation. Okay, this is the Cartesian product one. Now look here, now how to find out the relation, eh? We are finding the relation of, you know, from this order pair we have to select those order pair. Look here, 1 3, this 3 is more than this 1 by 2, right? Similarly we can find out this another one. Look here, from this relation, this is the relation from x to y I am going to select here. Okay, from this order pair I am going to select those order pair I am going to select here. One order pair is 1 comma 4, right? Look here, this 4 is how much bigger than this one? 3 bigger than. Okay, there is only one order pair we can select from here. This set of order pair is what? I have selected that order pair only from here, where this y, and what is the relation of this x and y here? This y is, the relation is what here? We can select here. y is 3 more. Okay, try the 3 more. Y is 3 more. Y is 3 more. Y is 3 more than x. Okay, this y element, okay, is 3 more than x. Okay, that element only I have selected here. Other element, there is no, okay, order pair in this set which is 3 more than, y is 3 more than, okay, x. That order pair only I select here from this Cartesian product. That's why this is the relation. Okay, this is the subset because this order pair lies in this Cartesian product. We can select another also or set of order pair. Okay, as I told, next that one also r, suppose there is r, I have selected here the next one. Look at xy relation from x to y. This is x is related to y, x is related to y. That one order pair I am going to select here. Look, okay, 1 and 3, 1 and 3. Okay, 1 I am selecting here this order pair, and next one I am selecting here. Okay, 2 and 4. Okay, this order pair I am selecting. Why do you know? What is the lesson here? Here is, we can tell x is 2 less than y. The relation is that one. Okay, x is, what is the relation of this x component, y component? X is 2 less than y. Okay, x is 2 less than y, or y is 2 more than x. X is 2 less than y. 2 less than y. Okay, less than y we can write here. X is 2 less than y. I have selected that one. Here also x is 2 less than y, this 3, and this also 2 less than y. Okay, like this we selected the order pair which is satisfy this relation. This is the relation one. I hope by this definition you are becoming clear about the relation. And don't forget that relation is the subset of Cartesian product. Okay, children. I'll just a minute, okay? Just a minute. It's waiting a little bit. Okay, this one. Okay, 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 students, look here. With this example, I think you are clear about the definition of relation, right? Now I am going to clear about this. I want to clear about this topic, okay? I want to clear the board. See here. Settings should be changed here. Mm, Here, children, look. Mm, okay, now I'm looking here. It's two less than y. Okay, that is okay. Now it's correct. Now setting is correct there. Now look here, I'm going to explain you about the next condition of the relation. Okay, here I'm going to clear about it. That is domain and range. Let's explain about domain and range one here. What is domain and range? Look here. Domain, first domain, okay, and then and range, okay. This topic are the very common for this heading also, okay, for this relation, domain and range of relation, domain and range of relation, okay. Domain and range of relation, domain and range, okay, of relation. Topic is like this, look here, range of relation. And look, children, in this topic, suppose if there is relation, okay, one relation is found there, okay. In this relation there is given the set of order pair, right? 2 6, 1 is 2 6, that the one order pair is 2 6, okay. And next order pair is there 3 7, 3 7, okay, right. And next order pair is given there 4 8, 4 8, okay. And next order pair there is given 5 9. This is one relation is given there, okay. Then we have to define this domain, okay. Domain we write there generally D only, okay. or we can write full form here also. Domain, right here, domain equals to mention there. Okay, what is the domain means? Domain means the set of, you know, first, component of the all order pair. Okay, that means here two first, then three, this the first, next first one is there, four, and next one, first one is there, five. Okay, when you take the first element from this order pair, one set will be formed which is known as domain. And if it is asked to find range is also the set. Okay, it is also the set, range is also the set which is formed by taking the second element, okay, of the this relation. Okay, what will be the set when you take the second element? That is 6. Okay, next one is 7, and next one is here 8. Okay, and next one is there 9, right? This set of the relation is known as range. Okay, like this we have to define domain and range. I hope you are clear about this. Okay, domain became there 2, 3, 4, 5, and range became there 6, 7, 8, 9. This is the introduction and definition of domain. While defining domain, you have to write domain is the set which is formed by taking the first element of this all order pair. Okay, and range is the also set which is formed by taking the second element of this order pair. That's called domain and range. Okay. Okay, now look there. So that's like okay, and writing the comment to the viewers. Okay, here's the dominant range that I have explained here. Okay, now see here, children. I want to clear this board. Okay, then I'm moving to the next one topic. How the questions are given. Okay, suppose there is given one relation is given there. Question will be given there. I'm showing here one question, and there is given R1. Okay, one relation is given R1. In this relation R1, there is given set of order pair. Okay, that is XY. This is set of order pair will be given XY. Okay, how to this set of order pair XY shows that there is given two dot here, shows that okay, what is given there y equals to given there 3x plus 1. Suppose this is the question. Okay, 3x plus 1 given their question. This is the set that are closed by the curly bracket, and if there is given range, okay, range given there, right, range given there, range is given there, its value is 1 7 10. Okay, 1 comma 7 comma and 10. These are the values of range given. Okay, these are the values of range. And as we know that domain and range, while explaining the domain and range, I told you range is the second. Second one is what this is the domain, this is the range. No, that's why range is y. Okay, in this question, first of all, what is given? Write here solution. Okay, write a solution, and given that here is y equals to 3x. Okay, 3x plus 1 is given there, right? Where y represents, right, range. Okay, and x represents domain. Here is given range already. Then asking, let's put here first of all this separately. Okay, range is y, that is 1. If you put 1 there, then here will be 3x, right? 3x plus 1. Then when 1 is bringing on the left side, it will be 1 minus 1, and here is remaining 3x only, right? Therefore here became x equals to 0. 0 by 3, it will be 0 only. Yes, then we form like this the value of, okay, and here next one, look here, x became 0, and similarly we can do this next one also. When you put this 1 7, okay, next one second, if you put 7 in place of y, then what happens there? 3x plus 1 same, right? And when 1 goes here, it will be 7 minus 1, and it will be 6, and this side will be here 3x only, right? Right here 3x. Then here this side what will be here? 6 divided by 3. Then we get the value of x, that is domain. Therefore x equals to 2. Okay, like this we have to write 2. X value is 2. Now when you put the value of this one y value is 10, then if you put the 10 there, then what happens? Look, 10 equals what will be there? Here is 3x plus 1, right here 3x plus 1 here. Okay, when 1 is taken on the left side, it will be 10 minus 1, right there 10 minus 1, okay. And here remains what is? This is 3x, okay. Then it will happen here 9 divided by 3 equals to x. Then we got here x value 3, 3 is a 9, that's why it will be here 3 only. That's why we got one set here. Okay, first one is there 0 value of x 0, right? And next value of x is 2. Okay, and then last one value of x is 3. Okay, this is the domain. Okay, that's why we have right here domain equals to right here domain equals to this is the set one, which is okay 6 number one a 0 2 3 0 2 3 is the domain. Okay, we found the value of x. No, here x is domain and y is range. Okay, this is the way to find the domain of the function when range is given. These are the ways. Okay. Okay. See here, children. Now now I want to go for the next topic. That is representation of relation. Okay. How to show the relation. I want to show you here. I want to clear it. Write the topic here, representation of relation. Right here, representation of relation. Representation. Representation of relation right there. And this is the heading. Okay, we represent the relation by different ways. Okay, they are first one is set of order pair, which is known as roster form also or tabulation form also. You can write it roster form. Okay, roster form. First one is roster form. We can represent the relation in roster form. Okay, number two is the set builder method, which is known as the description method also here. Here we have write a set builder method. Set builder method. Okay, we can represent set builder method right here. State builder method. Okay. Number 3 is there tabulation method. Tabulation. Tabulation method. Okay. Tabulation method. And next one, this fourth one is there OP. Okay, there is one. Okay, mapping diagram, which is known as arrow diagram also. Mapping or arrow diagram. Arrow diagram. Okay. By arrow diagram also we can show the DI. Okay, this DI is mapping diagram. And fifth one is there graphical method. Okay, graphical method is also known as lattice method. Okay, LATTICE, lattice method. We can tell it graphical method also. Graphical method also we can represent the relation. By the graphical method also we can show the relation. Okay, these are the different 5 methods by which we represent the relation. Okay. Okay, children, now look here. I am going to show you one example for each representation. Okay, look in this method we write like this. No, here is the relation like this R written. Okay, suppose there is given R equals to first there is given 0 0. Okay, suppose there is given here 0 comma 0, right? And next one is there 1 comma minus 1, 1 comma minus 1, right? And next one is there 1 comma 1, 1 comma 1. Okay, this relation is given there. Here is the relation. Look, when you do the square of y, x comes. X is the square of y. When you do the square of y, okay, this is y, it's a square. If you do it, this comes. When you do the square of y, then you will get x. Okay, and when you find out it's in set builder form, it will be written like this language. Okay, r equals to, we write like this. Now here xy is the set of order pair. Xy is the set of order pair, so that we write here, and x belongs to x. This one a. This is compulsory. X belongs to a and y belongs to b. This is y belongs to b. And other we write here y belongs to b, then there is main part is that, and we write here what is the relation of this and this. Look here, we get x. Okay, we get x when we do the square of y. X is y square. Okay, it is the method which is known as side filter method. When you do the square of y, x comes. And when write table, table should be written like this. Look, children, make table like this. Okay, and one this, and divide here x and y, right? Here write x, here write y, and first order pair, what was there? 0 0, right here, 0 x 0 y, and second one was there 1, and there was next one -1. Okay, and third one there is 1, here is also 1. Okay, like this we do, which is known as tabulation method. And when you show in mapping diagram, we show them in this balloon shape figure. Okay, where a is this, okay, and b is here. Okay, and first right here 0 1 1, and we join this 0 0 with arrow. Okay, compulsory to write arrow, and 1 is the square of, here is -1. Okay, so here arrow, and the another one we don't need to write this 2 1 here. Okay, because only one, we don't need to repeat this same element. Okay, the same element we don't repeat, but here's this one is also right like this. 1 we can write here, 0. Okay, here is -1, and this here also we have a 0 -1 1. Okay, here is 1. This is the way by which we represent the set of order pair. This is okay, which is relation. Okay, this method is known as arrow diagram, and when you show them in graph like this location, we use the graph paper where we wrote here this x, we write this x at this origin, we write this x, here we write y. Okay, and here we write 1, right? This is 2 in next one box. Okay, 3, right? And next one is 4. We show like this, and here also show 1 2, right? And here is 3, and here is 4. Like this. Let's we write the order pair. This is first one is where? First one is there 0 0 0 0 is this one, right? Origin. This is the origin which coordinates is 0 comma 0. Okay, and next one is there 1 comma -1. Down it is, here is -1, here is -1. 1 comma -1 is this point. At this point is 1 comma -1. And next one is there 1 comma 1. This is one run and one rise. This is okay. This is 1 comma 1. Like this we show the relation in graph also. Okay, which is known as a graphical method. Now look here, Celine. Now I am going to next topic, that is types of relation. Look here, that is types of relation. Okay, here is also something here. Right, like this here. Now I want to show you here the next one. Look here. Look, children, I'm going to write here. Next one, that is types of relation. Look here. Types of relation. In these types of relation, first one will be there reflexive relation. Okay. Number one is reflexive relation. Reflexive relation. Okay. And in this relation, what happens? Look here. Here we can tell it is the set of order pair in which x and y component are equal. X component is equals to y component. It is expressed as what? Relation 1 1, relation 2 2. Hence, each element of the set A in A belongs to the set, okay, belongs to the same element of the set B equals to A. Yeah, it is like this, okay. I'm showing here one example. This one is, suppose there is one relation given, okay, in which what will be there? One component, look here, there is another also one. This x component, y component both is same, right? And here is next one. We can tell x component and y component are same, okay. This type of relation is known as reflexive relation, okay. And number two, there is symmetric relation, okay. What is the meaning of the symmetric one? Look here. Symmetric. Symmetric relation right here. Symmetric relation right here. Okay. Symmetric relation right. And it is like this. Look here. In symmetric relation, like this. Look here. This example will be clear. Relation. This is the set of order pair in which relation will be like this. Look here. 1 is 1 comma 2, right? And its y component is 2. Then same of y will be the x in second order pair 2 and it's 1. Okay. This is called symmetric relation. Okay. Like this you have to write it. Here is first 1 2 then ending 2 and here is starting 2 then here is ending 1. Okay. Here is starting was 1. This is symmetric relation. And number 3 there is transitive relation. Okay. Right. So what is the meaning of transitive relation? Transitive relation. Okay. Right. A transitive relation. In this relation, this is also the set of order pair, right? It is the set of order pair. What will be in the set of order pair? In set of order pair, there will be, look, first one is 1 comma 2, right? And second order pair there will be its ending 2 comma 3, and there will be next one also, right? Its ending is starting, and now next will be formed by its starting point. This x component is ending point. Okay, that's y component. That's 1 comma 3, right? This type of order pair is known as, this set of order pair is known as transitive relation. Okay, first 1 comma 2, then what is ending? Look at this and this same, right? And then next order pair will be formed by starting the first component of first order pair and second component of second order pair. That's 1 comma 3. Okay, this type of relation is known as transitive relation. Okay, children. Now when you find the relation of inverse relation, okay, inverse relation is to change x and y only. In place of x, y comes, y in place of y, x comes. That is the inverse relation. Okay. Okay, from this it will be clear about the relation one. Okay, the types of relation is what? This type, so here reflexive and here 1 1 2 2, both are same, x component y component same, and symmetric one is 1 2 2 1, its ending is starting and its starting is ending. Okay, and this means it's order pair. Look, in this order pair, x component is 1, y component is 2, this one is this reverse one is 2 1. Okay, this is symmetric relation. And transitive relation, what will be there? 1 2, that 2 is here and 2 is here. Okay, its y component has been changed to x component and here is new, that is 3, and its x component and y component of second makes the another order pair, third one. Okay, such type of relation is known as transitive relation. These are the types of relation. Okay, and look like this one. I will make now next video. Okay, for the function. Okay, this is the video for relation one. For the function, I want to make next one separate one. Otherwise, it's too much long video here. Right? There are types of relation: three: reflexive, symmetric, and transitive. Transitive relation. Okay, and today this much only. Thank you very much.